Okay, that was almost like perfectly bad timing. Let's see if I can get the screen, not that one, this one, yay, okay. How's everyone doing? Hope you're well. What's there to talk about? Yeah, okay, so one of my friends mentioned to me that I should probably give a little introduction to the project for those that are coming in and looking at the VODs, since there's actually a lot of VOD traffic that happens nowadays. So just to give like a brief introduction to the project, this is Zepha. It's my voxel game that I've been working on for the past 6 years. I have been building it up slowly to try and make it actually a entirely moddable system. So the idea is that the engine part of the engine is just handling rendering and high performance things like generation. And then mods basically configure every single part of it, including like all of the content, all of the blocks, all the entities, even all the behaviors. Like the player controller right now is scripted. And by doing so, you can create composable games that are permanently stable, they don't randomly break when the engine updates, and are able to be remixed and created. I'm doing this because I'm making a game within it. It's a sci-fi sandbox game called Zeus, which I don't really have much made for yet, but effectively what you see on the screen right now is my first prototype content for it in the engine. I don't have my chat on my screen. One sec. I'm super prepared. I also haven't streamed in about wait, how many weeks? I think 2 weeks, but then before that it was like a month. Things have been really hectic for me due to life. Oh no! I think hectic for me due to life events, which I will talk about shortly. This is a great start, everyone. This is awesome. Okay. There we go. Chat set up. Okay. Now that we're good, yeah, so let's get into what we were doing last time. So I've stashed it right now because it wasn't compiling, and I wanted to be able to showcase the project really quick. But last semester, I had a university assignment to create a structure system in this engine. I basically did a self-directed study, and one of the options was just to work on my own work and effectively count it as school credit, which was incredible. And what I ended up doing was implementing this dynamic jigsaw-based structure system that's kind of similar to Minecraft's, but has a lot more configurability in how it places pieces. So for example, if I go structure, generate Zeus path X, you'll see that it creates this dynamically generated little path. So it starts with this crossroads, which is the X part of the path X, and then each piece is dynamically added into the mix. And then there's additional constraints which are applied. For example, the crossroads pieces here cannot be more than 3 pieces, or less than 3 pieces apart. They have to be at least 3 pieces apart. And they just continue to generate freely until they run out of pieces based on a different constraint. They generate in a different layout every time. That one is deceptively similar, but it is different. There we go. And basically it's just a really powerful system to be able to actually create dynamic structures. Hey there, NoClip, how you doing? Oh, thank you for the posture check. But right now, all of that exists just in modding code, which is fine for testing purposes. Obviously, if I have stuff in mod code, it's easy to iterate on and it's easy to test, but we want to be able to actually generate these structures at WorldGen. And generation is the domain of native code. So the project is split between C++ and JavaScript for the modding, where the C++ is like the engine side and does stuff like map generation, and then the JavaScript is for defining content. Right now, the generation parameters are defined using JavaScript. For example, if I go into the biome file, you can see that there's a lot of noise parameters which are used to tell the engine how to generate terrain. But the actual terrain generation itself, the mapgen core, is built in C++. Right now it has very limited structure support using the place structure function here, which is what I'm using to place these ugly little one-block pillar trees. But those are not built to use the new system, and they're also incredibly buggy, which is why the trees are one-block pillars. That wasn't an intentional decision. It was just that the structure system was breaking if I had anything bigger than one column. Which backend was this in again? OpenGL or Vulkan? This is Vulkan. It was originally made in OpenGL, and then I swapped it over like 2 years ago because I was getting really fed up with how OpenGL worked. Okay, so let's see. So let's unstash the changes really quick. Right. I need to git ignore the command history. Pop latest stash. Let's do that now. Git ignore. Where is it? Command history. I'll just command history.txt. Alright, so currently what we have right now is I was messing with changing the structure code. So you'll see that if I go over to the structure file, there's a whole bunch of parameters here which mirror the current JavaScript API. So structures are built as instances of this class, which contain an identifier, a size, and an offset from their origin, which is implicitly 0, 0, 0, which tells us what the center of the structure is. And then they also have a vector of nodes, which are just numeric indices, which say what type of block is there, a map of metadata, and a placement type, which refers to whether or not the placement is rigid, like a house, or terrain matching, like a path, where it has to conform to the slope of the terrain. This project looks so cool, thank you so much. It also has a placement depth, which is mainly for trees and stuff. If they want to contain roots or whatever, it lets them define how far into the ground they start. What do you like better with Vulkan over OpenGL? I'm scared to touch Vulkan because Apple needs to be fancy with their Metal API instead of being a normal company. I mean, first of all, to comment on the Apple thing, I've entirely abandoned the concept of getting this application on Mac at all. I mean, like, people routinely ditch Linux every time around. I feel like I want to at least, like, fight for my own team. But realistically, I have no interest in trying to support Apple when they're actively trying to make it hard to do so. There's nothing wrong with the Vulkan API, and them forcing metal on people is just a show of, like, walled gardenness that they do for everything else. But I really like Vulkan because it's a lot more explicit about how it functions. Like, the error checking is actually present as opposed to OpenGL, which I had so many issues with undefined behavior that just wasn't reported in. It's also a lot more modern, and it supports more powerful functionality, like, for example, direct buffer addressing. The ability to just index into arbitrary GPU memory if you pass pointers in, which is really incredible, and I do that for everything. And it's just very, very flexible. I mean, there's absolutely tons of boilerplate, and it's not for the faint of heart, especially if you haven't done much graphics programming before. This is my renderer, and it's 1,700 lines long, but it lets you do so much. Like, just to sort of present that idea, let me pull up RenderDoc here. And if I run the game and take a snapshot, just give it a sec to actually generate the terrain. There we go, I'll take a snapshot of this. And now if I open this, you'll see something kind of weird. So this is a rasterized voxel engine. It's not built with ray tracing, it's built with polygons. But if I go into one of these index commands, which should have a list of vertices and indices, and then we look at the mesh, you'll see something kind of odd. There's no vertex data in any of these vertices. The vertices are actually 0 length. The only thing that the CPU passes to the GPU with regards to the vertices is just a count and a null pointer. And because they're 0 length, that just works. And then what I actually do to generate the terrain, because we'll see if I go to the output state, I guess this one's off screen. Hold on, let me actually find a mesh that's on screen before I demonstrate this. Let's see. Nothing. My frustum culling's a little bit fucked. There's a lot of meshes that are rendering that shouldn't be. Where is it? Terrain, please? Hello? Okay, that's really strange. Wait. Does it actually not think that... Did I snapshot too early? Oh, I snapshotted too early. Hold on. That's my bad. There's not actually any meshes that are visible on screen. That's so gross, but so interesting. Yeah, so as J-Rude pointed out, yeah, this is vertex pulling. It's effectively where instead of having the vertex data within your vertices, you actually store it in a fixed buffer, and then you reference it in a face buffer, which is per face as opposed to per vertex, which shrinks the data a lot. Okay, so now that we actually have some things rendered, let's go into a face that actually has some information. Let's see. Let's just find one that's responsible for a visual contribution to the screen. This shouldn't be so hard. There's one, technically, that's on the screen. Okay, so if we go into the albedo buffer here, you can see that this draw command is responsible for this little sliver on the edge, right? If we go into the mesh viewer, you'll see that the mesh inputs have nothing, right? There's not even a visualization for it because there's no vertex data, but the output has a proper mesh. How does that work? Well, even though we don't have any vertex data, we do have an index value, which is this. This actually is also not per mesh, it's just a giant buffer that goes up to, I think, 500,000 that I encode once and then pass into every chunk mesh. But with the index number on the shader side, we can actually go and read from a different buffer for it. So if we go to the vertex shader stage, you can see that we have this push constants, which are effectively Vulkan's concept of uniforms. They allow you to pass data into the shader at any given point. And if you look at what's contained within them, you can see that there's 4 variables, which are actually pointers. You can see they're 8 bytes exactly because they're just pointers to other memory in the GPU, which is a Vulkan special from my understanding. State just contains some information about the projection of view matrices. Models contains just the positions of each chunk because it's indirect rendering. Or actually, sorry, that's wrong. Instances does that. You can see it has chunk position and face offset. And then encoded faces, this is kind of unreadable because it's all packed into a bajillion bytes. But effectively what this is it encodes a face for each of these groups of 4 indices. So if I go to the chunk mesh file, you can see the unscrambled face data contains a position, a size, a blend value, a reference to what model it should be, which is a specific face, and then lighting stuff that's currently unused. So that's what's encoded in this data, and then that references a model in the models buffer, which contains an array of 4 positions for each of the 4 vertices, a array of 4 normals encoded as floats for each of the 4 vertices, text coordinates for each of them, and then some additional parameters about how mesh mods and blending work. And effectively, every single group of 4 vertices that's pulled out of the empty vertex buffer gets indexed into the models array. Then we pull the actual positions and stuff from the model, augment them by the local positions on the face buffers, and then we render blocks. And that allows us to practically have 0 memory consumption for all of the meshes because, you know, they're all sharing the same models, right? I do also support stuff like entities as well that are not just grid aligned and copied from a shared buffer, and they are just using traditional rendering where vertices have data in them. I am considering doing some more advanced stuff with vertex pulling with them in the future, or at least indexing, but right now it's not really been necessary. But yeah, it's a really cool technique, and Vulkan makes it maybe not possible, but definitely feasible. You could probably technically do this with a ton of OpenGL extensions, but the kicker with OpenGL extensions is that you can't even test code if you have extensions on. If you're using any OpenGL extensions, RenderDoc just doesn't work, and it's one of the most valuable tools for debugging information on the GPU. Hey there, Trixon, how you doing? God, I hate my hair today. I went swimming yesterday in chlorine, and it's completely scrambled my hair. It's just like, it never gets out, even if I shower, and then it's just like, But yeah, so effectively, with the structure system, going back to that, every structure contains an identifier, size, offset, and then blocks to actually generate, and then it additionally contains attachments. Interestingly, I don't think I have attachments as a list here yet, which I really should. We should go back into the code and make sure that that's not wrong. But each structure has a set of fixtures, which can either be a source in which the structure spawns from, or an attachment in which additional structures connect to, or both. So, for example, if you had a tree, you might have one source that's at the base of the tree, which is where it generates from. And you might have one or more attachments where branches should go, where you spawn separate branch structures. A source just has an identifier and a weighting, because if multiple sources can share the same identifier, and then we base which one is selected off of a random function that is attenuated by the weight. And then they also have a series of initializers for counters, which behave as variables effectively that can be cascaded across the structures and augmented when structures are placed or queried when they're trying to be rolled, which allow you to add constraints to what structures can spawn where. When a piece is an attachment, it also has an identifier and a weight, and then it also has counter mutations. So when a piece is selected, it can query a counter and then also mutate it. So say we want to have a tree that has 11 branches. If we specify in the trunk that the branches counter is set to 11, each branch can have a condition that the branches counter is greater than 0 and a mutation to subtract 1 from it. And what that does is it effectively makes it so that branches can only be generated while the counter is greater than 0, which means we'll end up with 11 branches. And then finally, oh yeah, okay, so there is a vec of sources and attachments, and that's part of the fixture. So all we need to do is have a reference to a set of fixtures in the structure, which we don't. But effectively that allows us to create jigsaw-like compositions of structures to have more complicated data created just using simple structures. What are the benefits of this over instance rendering? I implemented vertex pulling render pipeline for Vevi a while ago, but didn't really see what the benefits were if I'm just rendering a ton of cubes or quads. Well, instancing is kind of complicated when you go into more complex structures and more complex optimizations for like quad faces. So like for example, if you're rendering cubes, you're going to end up with a bunch of extra quads that are being rendered that are inside terrain, right? If you render quads, sure, you can render them with only the faces that you need, but not only are you constrained to only cubic quad, or like only quad meshes, but you're also referencing a new like position in your instance buffer for every single quad, which is going to eat up a lot of memory, right? Or at least it's going to eat up a lot of draw calls. The benefit of vertex pulling is that it doesn't make any assumptions about the form of your quads, other than just the fact that they are compositions of 4 vertices, which can actually represent tries if you just set one of the indices, or set one of the vertices to be the same as a different one. And then you can also encode additional data in the face buffer that has information about like where the vertex, where each vertex is, right? And then since that data is static, it only needs to be referenced once on the GPU, but then it can be used as many times as you want. Effectively, it's just caching the contents of what each type of block's faces could look like, which allows you to just like save a lot of memory if you're using more advanced shapes and stuff that are not just like cubic meshes. It's mainly the memory savings that are beneficial. Okay, so we need to have a vector of fixtures in here. I'm not sure why it wasn't there in the first place, but I think that's just because I never actually finished this. And then what we need to do is we need to be able to have the place structure function actually use this information properly. So I have a really bad function in JavaScript which does this already. If we go to the structures.ts over here, we have... Yeah, okay, so... Oh, not this one, sorry. Generate.ts, yeah. This horrible 500-line JavaScript file basically represents all of the structure generation stuff that we have, which is really gross. Hey there, Luma, how you doing? So I think there's even some go-tos here. Yeah, oh my god. We're gonna try and make this quite a lot better when we actually implement it properly. Okay, so... if we're going to be generating a structure, let's take a look at this really quick. So I need to remind myself on how this works because I haven't actually worked with it in several months. So generate structure recursive takes a dimension and a position, obviously. Then it takes a generator state, which has counters, structures, and that's just debug information. Cool. It has a depth for how deep within the generation tree it is, which I believe affects how many attempts it gets. An attempts state, which is just how many attempts have run at all. Then there is the structure itself. Cool. Which is given. Where did that go? I got teleported. No. The structure itself, then the fixture index within the structure that we're referring to, and then the orientation of the structure. Okay. And then it looks like we do a bunch of gross copying stuff. That's really disgusting. We're gonna make sure that we don't do that. And then we have, we apply all the counters to our fixture. Okay, so when we select a fixture, we apply all the counters from it into our state, which I guess is kind of where we run into issues with, like, copying stuff, like what's up here. Because if you imagine that each of our structures has a state which is going to be affected by children of it, sometimes the state needs to inherit some values, and other times it needs to generate new ones. So I think in C++ we're probably going to use a vector of pointers, probably shared pointers, maybe. Yeah, we might make them shared pointers. So a vector of shared pointers which go to key value pairs for the counter values. Because we can then just duplicate the vector and shadow any variables that we want to have be overridden by sub trees. Okay, so we get a state, we apply all the counters, and we add the structure to the list of structures, which is used to prevent it from overlapping with anything else. And then we push it into the list. And then for each of the fixtures that is not the source, we try to generate a child structure. This is partially kind of broken. Something that I don't like here is that this is a depth-first search. Because effectively what happens is we choose a structure to generate, and then it generates, and then for each of its children, we try to generate it, which then generates for each of its children, which means that in the end, we end up with just a single line of structures. And we can see that if I go into here. So if I let the game generate really quick, let's give myself a structure origin, and I'm going to go structure load Zeus path X. And you can see that this structure here, this is the actual file that gets loaded, it has 4 attachment points. But if we actually try to generate this structure, we're only going to ever see one get used. Generate Zeus path X. You can see that this one was the source, and then this one was the actual connection that got chosen. Ideally, all of these would have connections, but because we limit the number of paths and it's a depth-first search, we effectively go down this entire path in order. This one's, like, conformed to the ground, which is why these are in the wrong spot. And then we end up getting to the end where we run out of pieces to place because we've reached the maximum value for the counter. And then we go all the way back up the tree trying to spawn more structures, and then we get finally back to here where it wants to place the next ones, and it can't because there's no counter, there's no paths left in the list of paths that can be generated. So what I want to do is have it be a breadth-first search by default. So I want it to generate a structure, then enqueue all of the fixtures for that, then generate each of those in order and queue all of the fixtures for that, and keep on going. Which means that effectively what we need to do is we need to maintain a list of children fixtures to generate, as well as the states that each of them should have. Because the states are kind of copied on write. So the states are basically just the counters, right? So if we have a structure that sets like some value to 3, and then it has 2 attachments, and then each of them reduce the value by 1, then they should each have a state where their value is 2, unless they're set to overwrite, at which point they'd each go down to 1 because both decrement by 1. But we need to be able to support this shadowing behavior because in a lot of times, you just want to be able to have a structure that generates a certain number of children in each direction, which means that the counter shouldn't be shared amongst all branches, right? So each list item for the structures to generate needs to have a fixture, a origin position. What is happening? Oh, my zoom is... Wait, that's sprinting. Why does sprinting reduce the field of view? I swear that's backwards. That can't be right. Was it just a bug in my player logic? Probably. There we go. Okay, it's working now. What are some things that you want to add to the project in the future? Like gameplay, other entities, etc. I love the videos and live streams. Thank you so much. Yeah, so things I want to add to the game in the future. I have a really, like, complex idea that I want to make that's probably going to take several years to make if I can work on this project full-time, which hopefully I'll be able to in the near future. But effectively, I want to make a whole sci-fi survival game where you end up crash landing on a planet with a bunch of really fucked up alien tech that ends up having you shapeshift between a bunch of different forms in each biome. So the idea is that every biome has its own environmental challenges and its own forms that you can swap into. And as you go through the game, you end up collecting more forms that you can shapeshift into and more upgrades for them. They each have like an independent little tech tree of abilities that they can unlock. And the broad goal is to escape from the planet, but in doing so, you're going to end up doing a bunch of exploration and automation and building. I really want to have Valkyrian Skies-esque vehicle, like block entities. I've been building the chunk system up so that that's going to be possible. Like right now, chunks are all gridlocked, but there's nothing that's technically forcing them to be like that other than just like collision and stuff. So that's something that I'm hoping to have in the future, is the ability to have like vehicle entities. Yeah, Valkyrian Skies is amazing. I love it so much. But yeah, that's the very elevator pitch idea, I guess. So yeah, if we want to have this structure system be a BFS, we're definitely going to need that list of structures to generate. This might actually benefit from being its own file at this point, because MapGen's already pretty long. That said, it's going to be hard to compartmentalize and like give the structure generation references to just the parts of MapGen that we need. So I think I'll keep making it one unmaintainable, horrible file for now, and then when I finish working on it, then I'll split it off. But yeah, basically the gist of it is that after we place that one structure, we place all of its children. I think. Hold on, where are we? This is generate structure. Okay, so this is for each fixture. We find an attachment from the fixture, then we attempt to place it, and then we... Wow, there is a lot of stuff. I don't remember what most of this does. I mean, at least I have comments for it, but damn, okay. Then we apply mutations, sure. I have no idea what this thing is about. Oh, I see, I think. This is all just rolling to try and find a valid attachment. Display debug stuff, recurse deeper, blah 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 blah. Okay. Cool. And then finally, after we generate that structure, because that's done here, then for each of the structures that we generated, we actually place the blocks, which is simple enough, right? So, let's see about starting this. So, we've got a job and a position. The job is effectively representing a fixed set of chunks that are generated by the generator. Then we have a structure definition, which is a member that is our C++ struct that we showed. That's just mimicking the other structure. And then you feel a silly presence approaching. Hey there, Johnny, how you doing? We're going to comment everything out here. So the first thing that we need to do is roll either the source, or we need to handle rolling the source outside of it. So I think we'll roll the source inside for now, and we can pull that out otherwise. Each structure has a number of sources that can potentially be chosen. That's one of their fixtures. Gonna sleep soon, but I figured I'd say hi. I was at FOSDEM yesterday. Is that a convention or something? So we need to be able to choose a source from the structure. And then we need to set its counters based on that. And then we need to append all of the children that it should generate to a list. We also want to put a set of committed structures into the list, because we don't actually want to place any blocks in the map gen at this point, because doing so is just going to make a mess for ourselves if we end up not being able to fulfill the structure. Because since there's the whole counter system, it's entirely possible to make a structure, a structure to be generated which can't actually exist, at which point it should discard the whole thing. And if we are already placing blocks when we're not sure if the structure is going to exist, then it makes it really hard to undo. It's a like 6 out of the 8B people on this planet were there. Holy fuck. 8B people. I feel like I'm hearing a bunch of words and I don't know what they mean. Days of 8 billion. Oh, is it some sort of... Oh, you're just saying like 6 billion people? It's a FOSS convention, which means it's free, which means there's so many fucking people. Oh god, that's stressful. I went to PAX in September, and it was like relatively small as far as conventions go, but fuck, it was huge to me. I'd never been to a convention before, and it was really stressful. Yeah, that's really cool though. Was there anything interesting there? Like, I don't really know. I guess I'm assuming there's probably like a bunch of FOSS software that was being showcased. So we're gonna have a vector, which is going to contain a structure pointer, or I guess a reference. PAX was fun once, the stinky people makes it hard to justify going again. The stinky people. You know, I guess there was a bit of body odor there. There were a lot of gamers, let's be honest. Mozilla, GCC, LLVM, FreeCAD, Gentoo, VLC, etc. That's really cool. That's a good mix. I'm really excited to go to PAX again next September because, I guess, kind of big news that I guess most people in my Discord probably already know about. A business partner and I managed to secure investment for a game studio that we're building up together, and we're going to be at next PAX West as exhibitors at 6, hopefully, actually showcasing a game that we're making, which is really, really exciting. But yeah, I mean, if you're in the PAX West area, definitely come say hi. That would be very cool. Yeah, I don't know if I would go to PAX again just as a viewer. Like, it was a lot. It's definitely a cool event. I just don't know if it's my thing. You're not going to be in the PAX West area. Fair enough. Big far, yeah. Okay, so we need to have a reference of structures, which are going to have... So this is going to be like placed structure. And it's going to have a structure reference, it's going to have a position, and it's going to have an orientation. And I think that's all we need from this. I live all the way in the land of beer, fries, and waffles. There are so many places that could mean. Watch streak reached. Johnny the Carrot is currently on a 3-streak. Wow, look at that. Congrats. Wait, why did it attach that to a specific... Oh, did you choose to publish? Okay, cool. Belgium. Ah, gotcha. I am embarrassingly not worldly. I know next to nothing about places outside of my immediate purview. I want to say high school education failed me, but no, I just am really bad at paying attention to things that are not code. You don't think that's what worldly usually means? You might be right. Aware of the world, I guess. Okay, so here's a small test to determine how bad or good it is in your case. What is the capital of Belgium? I have no idea. I mean, you could ask me what the capital is of a US state, and I'd be like, I have no idea. Like... Better to say that than what other people said? Oh god, what did they say? Was there any, like, really embarrassing things? Capital of Belgium is waffle. They said Spain? That's where the waffles come from. Wait, okay, what actually is the capital of Belgium? Brussels, okay. Got it. Spain. Wait, Spain? Okay. Yeah. Isn't Brussels in Australia? Spain? Yeah, Spain. Well, I mean, hey, that's like saying the capital of the US is Canada, so... Oh shit! Okay, I swear to God I said that before you posted that. That is weirdly cursed jinx timing. Yeah. Alright, so we have our place structure, and we also need to have our structure state, which is going to contain a vec of counter instance pointers, which we're going to make shared pointers for now. I might eventually just make raw pointers that then delete themselves when the structure generation's done. I saw it pop up after you said it, so I believe you. Okay, the stream is validating my beliefs here. The only reason I know Brussels exists is because of Down Under by Men at Work. Like, Australia. I feel like I'm betraying the fact that I am outside of writing code just a complete moron. Okay, so our counters are going to have, I guess they're gonna have a counter initializer. I don't like this, because that's gonna specify their properties, and then they're gonna have a... Then they're going to have a value. Oh, Men at Work. Okay, got it. Yeah, I don't know the lyrics, but I know that that's a song. So we're gonna have a structure counter initializer and a value, and that's gonna be our counter instances, and then our state is going to be a vector of shared pointers of those instances. All you need to know is that you're now holding a Vegemite sandwich. I'm a big brain in engineering, but don't ask me about anything else. Yeah, I sometimes get asked about math stuff because I write code and do engine stuff, like matrix algebra things, and I'm just like, please, I'm not that subclass of programmer. I have ingested all the matrix algebra I needed to know to pass my university courses and then immediately discarded it. Well, you're one leg above me then, so congratulations. Okay, so our structure states need a set of counters. And then we may as well put in a depth. I think that's sometimes useful. I'm just trying to figure out, like, preemptively what we're actually going to need here. You have a cool voxel engine, I don't. Alright, there we go. Yeah, that's my my winning play. Alright, where's the state? Generator state. It's counters and structures. I guess, technically, I don't think we're going to use a recursive function, so I don't think we need to have anything in structure state that we could just have in scope, like lexically. Like if we have a void generate structure, which takes in a job, because everything needs a job in the map generator, and it takes in a origin, and then it has a structure, and then it has... I guess this is just the same function as over here, but let's just pretend it's not for a second. And then we have a vec of place structure, which are placed structures, and then we have a for loop. Oh, and then we have a vec of queued structures, which is going to be empty, but that's going to basically be all of the fixtures that need to be placed. And then we end up in placing something to do with our structure here into it, right? It'll have more metadata, but whatever. Then we go well queued.length or .size. Then we're gonna go let first is going to be queued.front. That gives us, yeah, reference to the structure, cool. And then we're gonna at the end go queued.popFront. No, pop back, is that's not the right one. Removes the last element. Unshift? God, what is it? All of the names are so frustratingly bad. Wait, is there just not one? I guess that makes sense, actually, because this is a vector. I got nuclear engineering, which is like, I just like doing dumb things with computers. I wrote a diagnostics library in C++ to use in my compiler. It's super fancy and I'm proud of it. Oh, you're writing your own compiler? That's really cool. People keep on assuming I know more about computers than I actually do. I get asked frequently if I'm a CS major, even by the same person repeatedly. That just sounds like they have memory loss. Pop back, it was in the list. But that removes the last element. Yeah, I need the first one. But that's actually just an indicator to me that I have the wrong data structure. I need to have a stack here. Not a stack, a queue. Because I want to insert at the end and pop from the front, right? So we take the front and then we're going to do a pop, which will remove the first element. Perfect. There's a pick encoding in the Discord. Cool, I'll check it out after. Actually, wait, I'm gonna look now because I don't know what your Discord username is. Okay, well that makes sense. Fair enough. Alright, so I was originally building from scratch, but for the sake of time, I'll use LLVM. Cool. Okay, so, well, we have something. Let's go struct. I can't use the word struct, and if I use stir, then it looks like string. I hate this. Okay, so we have the structure, and then we actually need to place it, which should be easy enough. We're just going to copy some of the implementation from this part of the code. I'm just going to grab the JavaScript for now and comment it out for reference. So we're not going to have the maximum global attempts yet, although we will write a to-do max global attempts. Strict. Oh, that just looks like I'm trying to say strict, though. Structure is too long. Struct feels wrong. I mean, I don't really care about this argument. I could change the name, but like, I don't know. Structure is just so many letters. Like, I don't like having variables in the hot path where I'm going to be writing them a lot, like with a lot of letters in their name. Struct 2 electric boogaloo. My struct. Have you ever seen people do that shit? Where they prefix variables with my? It's really cursed. Okay, so we need to initialize the counters. This is going to be weird because we're not going to do any of that. So I guess, oh, the weird thing is, okay, so this queued structure needs to have a state attached to it. So we're going to give it a structure state. Yep. Cringe was blocked. Yikes. Okay, hold on. I'll fix that. Call it S. Definitely a good name for a variable. I should just call all of my variables single letters that start from A and keep going. That's a great idea. They all prefix... if they prefix everything with my, then I assume it's all copy-pasted, right? Like, that's just like from Stack Overflow. You have a better name? Oh no. Alright, so our cube structure needs a structure state. It also needs a structure that is the structure. I think I'd like to call this queued, but this is called queued. We'll call this queued structures. There we go, okay. So now we're gonna grab the structure itself, and we're gonna want to initialize the counters. Let's actually generate this for now. We're gonna create it. This is going to have, state is going to be equal to counters, which is a vector. And then depth, which is going to be equal to 0. And then structure is going to be equal to structure, as one might expect. And then this just needs to be in place because this is a queue. There's no member function to in place. Oh, it's just because it can't type infer. There we go. Get a language that allows identifiers to be any Unicode character, then you can bring the Greek alphabet when you run out of Latin letters. There's someone I know that genuinely does that, and they have a special keyboard mapping that lets them hold a modifier key and type a bunch of Greek letters like phi and shit. They're a Haskell programmer, so, you know. It only slightly hurts the very fiber of my being. Okay. So we're initializing our queued structure here. Truly a different breed. Mac lets you type a bunch of Unicode stuff by pressing Alt. Yeah, that is a thing, I think, in Windows and Linux too, although all the formats are different, which is annoying. Oh, wow, what a beautiful name. Okay, so we don't care about the debug entities or copying the old state or the counter index, but we do care about initializing the counters, but we're not going to do that yet because the counters don't really work yet. Okay, and then we're going to... So this expects a fixture int, which makes sense. I guess what we should do is include within this... We can actually just probably get rid of structure state. It's all just queued structure, right? So we're going to have a structure, then we're going to have a U8 fixture int, or U8f. We don't really care how it gets compiled. And then we're also going to have a... Actually, is there any reason that I have the index? Can I just use a reference? I know that that's like slightly less memory efficient, but that would make it so much nicer. Let's try doing that. Okay, so we have our fixture, we have our structure, and then we also need an orientation. I have a shortcut for a Greek keyboard, but that's because I occasionally have to write science stuff, which often uses them. Yeah, that makes sense. That's very fair. Okay, so our generate structure, now instead of having state, we're just going to inline initialize counters and depth and structure, and then let's just say fixture is just going to be structure.fixtures. I guess I can't easily find one. Oh, that's probably why I'm using the indices, is because I want to grab the indices and then filter. No, that shouldn't matter. Okay. You have a good variable name? What is it? No! Oh god, what is this? What is this Unicode character? I don't even know how to figure out what that means. I have like zero experience with graphics APIs. How would you go about making a UI/menu system? Would you use some form of 2D API or would you use Vulkan? So personally, I like rolling my own menuing system, but that's mainly because I'm I'm a UI designer at heart. I've done a lot of years of web development, and I feel like all of the big libraries that exist are so distinctly shit in weird ways, and like you can always tell which one it is. It really bothers me a lot. But like I don't really have a problem intrinsically with using them, I just wouldn't use them myself. I've got a graphics API that I've been hand-rolling for Zepha, which is kind of a huge waste of time. But hey, if I'm gonna reinvent the wheel for everything else, I may as well here too, I guess. I want Web 1.0 back, bring back the interesting site designs. Okay, yeah, that's fine. That doesn't make me really sad or anything. I'm just a casual enjoyer of modern design, but it's fine. Okay, we're gonna have the orientation start with 0 rotation. The weird thing is, like, these parameters should probably be randomly generated, which means that I need a function to pull a valid fixture out of a structure. So let's actually take a look at how we do this. So when we call generate structure rec, it already gets a fixture in. And that's created here using this logic. It's a valid identifier, but what? Wait, that specifically is a valid identifier, like that \u stuff? Hold on. Let u0d9e equals 0. What the hell? Oh no, it's Among Us! It actually renders as Among Us! Wow, okay. Wait, can I... Redefinition! It knows they're the same! Oh my god! That's incredible. Okay. That's amazing. I guess, like, having Unicode characters in C is a thing that some people do for memes. I've never really seen anyone do it intentionally. I guess you could. Hold on. Lambda character. You could. I could go and change my... Where is my macro that I have? Not that one. I have a macro somewhere for... Yeah, this one. I could change this to a lambda. I don't want to, but I could. This definition here is for doing block expressions, basically. It just aliases to an immediately invoked lambda. So if I want to do something that is like a single value, so like if I want to go let x is equal to, and then I want to do some stuff in here, I can go if rand mod 2 is greater than 0, return 5, return 3, right? And internally this gets bound to a lambda that's immediately invoked, and then we end up getting the result. It's a block expression. Wow. JS lets you use emojis, which is beyond gross. Can you include the RTL override character in an identifier? I guess let's find out. Let u202e... That didn't work? Let u0d9e... Okay, I guess you cannot. Like, if there's some function that for whatever reason has spaces or colons or whatever in the function name, can you still access it? I assume you can probably do that if you use the Unicode entity. What is the Unicode entity for a space? 0020. Nope. Character space cannot be specified by a universal character name. It's like a specific clang warning. That's super weird. Hey there, Darksoon, how you doing? That's super strange. What about 21? What is 21? Exclamation mark. Okay, so it looks like they've got like whitelisting for some of them. Or blacklisting, I guess. You know Unicode / ASCII for like code space by heart? Oh my god. That makes sense, I guess. Letting that in there would probably break a lot of documentation and code editors. Fair enough. This stream has been thoroughly derailed. You're right. I'm sorry. I come in and the first thing I see is you trying to declare a variable name with \u. Well, they made me do that with an Among Us. They gave me an Among Us to put in here. Look at it. It's awful. Standard forbids certain characters for universal character names. That's lame. But whatever. Okay. I'm gonna actually try and focus just a little bit here. So, the JavaScript code for choosing a fixture. The way that it works is it grabs all the fixtures and finds the ones that are only sources. Then it reduces them into their total weight across each of them, because the weight's like an integer. Then we roll a random value. Then we grab it by finding the first one that is within the weight range. And then we... Why is that a reduction? Oh my god, why did I write it like this? And then we throw if we don't get it, and then otherwise we return it. So we can write this a lot simpler in C++ probably. Also, did you know that this is valid C code? Void test xy int x int y. Oh yes, I have seen that before. I've seen that, it's super weird. Alright, so let's go roll source fixture. And we're gonna take in a structure. Then we're gonna go, let total weight is going to be 0, then for let and fix of structure.fixtures. We don't actually need let, we can do const. Oh, const. Oh wait, let, I'm stupid. Let is already immutable in my macros. So then we grab the fixture, and then we're gonna go if fix.source.hasValue, or let's just do a double negation. Then we're gonna go total weight plus equals fix dot source dot weight. And it doesn't like that because this is a float. Oh, I guess that's fine actually. Sure, float. But this is also const. This needs to be var. Okay. Now, why do my arms hurt when I sneeze sometimes? That's a problem for your doctor. Okay, so we have this. Then we're gonna roll a number. So let's go var roll is going to be, and for now we're just gonna do rand. Oh, I don't want to do rand. Hold on. How do you do a C++ floating point random generator? I know there's like a standard library thing for this. Okay, this code which I just found, I don't think is the way to do this. People don't like rand. Okay, here we go. We'll go uniform real distribution float, or F32 distribution 0 total weight. And then we're gonna go default random engine gen. Then let roll is going to be equal to distribution gen. Okay, cool. Eventually, this is beneficial because we can abstract this out into the source, and then that gives us like a consistent random engine, which will be, yeah, because it'll be a consistent seed. I'm not going to do that yet, because I don't want to pretend that there's actual consistency yet when there isn't. I'm just trying to like make this work. Does anyone know if this is inclusive or exclusive? Uniform real distribution. You can make it consistent. I guess okay, fine. That'll be a good band-aid for now. Do we know if this is inclusive? Okay, it looks like it is not, given a really quick Stack Overflow post. Okay, so now we have our roll. And then we need to go... We just need to go for... Or we'll go var accumulated weight. Accumulate is equal to 0. And then we're gonna go for let fix of structure.fixtures. then we're going to go if not fix.source continue. And then we're going to go accumulate plus equals fix.source.wait. Then if accumulate is greater or equal to roll, then we're going to return fix. I was once in a Discord server where I could not type the word accumulate because people hadn't touched grass and they had to block a certain... Oh. Awful. Wow. That's... Huh. I feel like AutoMod is smarter than that. Did they just, like... Weird. Okay, why can't I return this? Oh, because it's an option. Oh, also we don't have a return type. That would do it. Okay, so we'll return the fixture. Asterisk word asterisk is the filter, geez. Okay, so something that's kind of weird here is that this isn't handling counters at all. So I'm gonna write to do should handle counters. For real, for real. But for now, that works. And then I guess we'll throw a new error, or we'll throw an error here. This should never happen. Because hypothetically, this should never ever not be able to be computed, right? Or I guess we could just, actually, there could be weird floating point imprecision, so let's just return fix, but I have to go structure.find last, std find last, find, okay, hold on, find last vector C++. My old IDE used to have like little generators for these, and then I never actually learned how to do them properly. Although actually, maybe we'll just keep it like this for now. Upper bound. Upper bound. I don't think this is what I want. We're just gonna leave it like this right now, because technically there's a case where there's no source fixtures, and we should also handle that. In fact, I'm gonna write to do something if no source fixtures, to do handle floating point imprecision by returning the last valid source fixture. I know I'm just writing more to-dos than code, but at a certain point you just need to make sure that it runs. Okay, so we grab a structure. Or I guess we should do this here where we go roll source fixture. Oh, then this should also be a, yeah. Roll source fixture structure. You want to measure your stupidity. In what way? Okay, so we grab a random structure. Okay, let's ignore the counters for now. Did you know by heart the result of short 1 plus short 2 is an int? Kind of. I mean, like, it's one of those things where if you asked me, I probably would have said it would be a short. Like, if you just said, like, oh, what's it do? I'd probably go short. But if I was writing the code, I think I'd feel kind of queasy about it, and I'd look at the return signature, because I've encountered far too many places where it does just cast up, and it drives me insane. So, like, I guess, to be more specific, I think I wouldn't know it if you just asked me on, like, a test. But if I was trying to write code, I would probably be like, something smells wrong here. So we won't apply the counters. The casting up is probably an optimization or something. I thought it was to prevent overflows, but I guess, like, if it is... Yeah, you're probably right. It's probably just to do with, like, the fact that all registers are usually 32-bit. I don't think it's just to prevent overflows. I think that it's like got something to do with internal hardware as well. I only recently learned that each side of an expression is promoted to an int if the rank is less than int. Yeah. That's what the carry flag is for? With overflows? I mean, like... I don't know. Maybe you're right. Okay, so we want to... How are we going to do this? The overflow flag. Yeah, okay, that makes more sense. Why is this in braces? I think it was just for organization. So let's go, no, what? ivec3 min-pos is going to be equal to... we're going to subtract... So we're just going to take the negative of cube.fixture.pos. And ivec3 max-pos is going to be equal to the min-pos plus fixture dot... or structure dot size plus 1. Why is it pissy? Oh, because this is a uvec3. Got it. Either way, both sides of an expression are cast to a common type. I feel like they should have just been cast to the larger of the two data structures. Like, if you did 2 shorts, or a char and a short, it should end up making them both shorts. Okay, so... the hell is make collision volume? It's just a thing that returns a tuple. Okay, thanks, Ari. That's really helpful. Okay, and then we push that into placed structures, it looks like. Which I guess should maintain a bounding box. I think I already have a bounding box type. I don't know where it is though, and it's 2 vectors, so I don't really care. They are after promotion int is a minimum, and that's after that's the larger of the 2. Wait, does it really promote to an int if you do 2 chars? Why? Okay, hold on. I need to... This is a derailing, I know, but... I need to know something. Okay. What? No. Compilation failed. Oh. Okay, so if we just do this normally, a plus b, then it does that. And if we do that, it changes that to a byte as opposed to a D word. So it's just changing the type here. Okay, what if I throw this here? We're all learning C++, isn't it? Yeah. Okay, so it looks like this compiles to the same as the cast. That's so fucking weird. I don't think they're promoted to integers. Unless I'm not understanding some stuff about the assembly here, but I don't see anywhere, unless edx and eax are always integers, which I guess could be the truth. Yeah, that's probably it. Shit, you're right. It's crazy to think there's not optimizations for 1 byte addition. Oh man, that makes me kind of sad. Okay. Well, everything's terrible. Computers are awful. Oh, okay, fair enough. The way I'm understanding this, int math is just more efficient than 1 byte, I guess. Why can't I return this? Because it's a const. That's probably for the best. How'd you optimize that though? All the registers are 64-bit anyways. Is that true? I thought that don't modern CPUs still use 32-bit registers and they just use 2 of them at once for 64-bit values? Smaller ones are subsets. Okay, yeah, sure. So a register can be like subdivided though. Okay, I don't need this to be mutable. And I don't need this to be mutable either. And that means this doesn't need to be mutable. Okay, there we go. Cool, so we have our minimum and maximum position. We don't care about the bounding box, and we need to push this into placed structures. You only get one 32-bit register per 64-bit register for some reason. No. Say that isn't true. That's awful. How many 8-bit registers do you get per 64-bit registers? Smaller ones are inside bigger ones. RAX contains EAX, which contains AX, which is split into AH and AL. Wait, you only get 2? What the fuck? No, that's terrible. Why? What's wrong with it? Why is it borked? Oh, alignment. I hate alignment. Alignment is the root of all evil. This is definitely wrong. Oh yeah, that reminds me, x86 64 with AVX 512 adds 512-bit registers. Oh no. You'd have to shift to get the upper 32 bits. The SIMD registers work how you'd want them to? Okay, fair enough. I mean, I guess like the whole point of registers is to be fast. Like, if I'm correct in my assumption, RAM is not held to the same constraints, right? Okay, I need to be able to sum these, which is a very simple operation. I'm just going to create a function for it so I don't have to think about it. In fact, I'm gonna define these explicitly, and I'm gonna go static sum orientations, or add orientations, which is going to take in a and a B, and it's going to return Also, I want this to be a U8. We're gonna static cast orientation, and we're gonna go static cast U8 A, static cast U8 B, mod 4. Cool. RAM is slow as fuck compared to registers. Yeah. It's also like, you may have been told the heap is slow, but so is the stack. Equally so, the slowness is not in the heap or the stack, but rather how more of it is allocated. The stack's allocations are wildly faster than the heaps, but once you have them, they're just as fast. Wait, really? The heap is just as fast when it's already allocated? Like, if you create a like, C++ array and a vector, the vector's heap allocated, the array stack allocated. You're saying that if you're just mutating existing elements in it and not adding or removing, as long as, like, you ignore the initial allocation costs, they're the same speed to manipulate? Wow, okay. I genuinely had no idea. That's really cool. Why wouldn't they be? They're both in RAM? I assumed it was something to do with the lookup cost. Like, because it's in the heap, it has to be... I guess that doesn't matter, does it? Because they're all just pointers. Huh. Wow. Structure. Add orientations. Cool. Both heap and stack is just memory. Yeah, fair enough, fair enough. Seg faults are managed by hardware. The stack and the heap aren't really discerned if you go down far enough. Yeah. Thing is, depending on how you use it through the stack, you may be more... Yeah, that's fair. I am familiar with, like, caching stuff. Okay, so this should place the structure. The problem is that cube.fixture.pos is just a position relative to, That's actually weird, because this is just a position relative to the structure. What we want is a global position, which isn't present in queued structure at all. So that's something that should be fixed. So we'll do that. Then we're gonna go cube.fixture.pos plus cube.pos. Then that's gonna also inherit that because it's copying, or it's adding to minpos. Then we're gonna go, the position is going to be cube.pos. Here, okay, cool. So that should add the structure to the place structures list. Then we don't care about the debug stuff, and then we're gonna go to do recurse down structure children, which we're not gonna do right now. And then we're going to go and return our placed structures. Which I guess we should, Oh, this is a weird question. Okay, so C++ folks. If I put this vector in a unique pointer, it will not copy the vector when I send it out. But I've heard weirdly conflicting things here. Because this vector is never used again, will compiler optimizations just cause it to be initialized at the call site anyways, making this a free move? Like, it won't actually move anything because it'll already be initialized where it knows it needs to be? I'd like that to be the case. Okay, so this vector, it exists in the stack in this function, and I'm returning it here, which in unoptimized code will just copy all of the values, right, into a new vector. So if I just go like, you know, let structures is equal to generate structure, job, pos, structure. In unoptimized code, this would copy the entire vector, right? Yeah, it won't do that because it's smart. Yeah, my question is just, if you actually run the compiler with compiler optimizations, what it'll actually do is it will generate the vector at this position, in like this function stack, and then it will just alias this to that, and then it will never actually do a move, right? You should be able to force a move with std move, but you don't need to, right? Big but. Okay, let's see. What is it? Your vector cannot be const. So if I made this a const over here, well, I guess I can't in place anyways. Huh, okay. Interesting. So, forgive me for not entirely understanding the meaning of move here. I thought that move just meant that it called the move constructor and then didn't actually, like, do all of the work necessary to a copy because it knows that it can leave the original value in an invalid state. Does it actually not reallocate at all? Like, I thought the point was just, like, if you move, then you don't need to be concerned about what the original value remains in. The stack part of the vector is copied. Oh, okay, so the vector's move constructor involves copying the heap, or involves moving the heap reference. It's just an std vector. And because it's a move constructor, it doesn't copy the underlying data. It just gives the pointer to the heap allocated data to the new vector. Okay, so it's not that it implicitly just copies or like initializes it over here. It is doing a move, but the move constructor of the vector doesn't copy the data. If this was an array instead of a vector, would it copy the whole thing? It wouldn't optimize it or anything? Huh. I thought it would. Yeah, compiler probably optimizes it. Okay, fair enough. I assume if you made it an inline function at least, it would optimize it, because it would all technically be in the same function body, but... yeah, it mutates the original value. Also, like, if it's a return value, right, it'll already be in the right spot for it to be a local variable. Or, that's the original question I was asking. So, the fact that this placed structures here is returned means that it wouldn't even actually do a move, right? It would just already be initialized, like, down here, where it's needed. Yeah, okay. That's what I've thought I've heard in the past. I just wasn't sure about it. Okay, cool. Thank you. Alright, so we're gonna call generate structure in here, which is going to give us a list of place structures, and then for each place structure, we're gonna call it S. No, we'll call it stir. We need to actually place it in the world, which is gonna be just great. I love this horrible block of code. This was from the old structure system, but I think it's probably accurate, because we don't care about this. We care about stir dot... I guess we'll go stir.minpos.z is equal to 0. Stir.min... Or we'll go, var z is equal to 0. Z... Or is equal to stir.minpos.z. Z is less than stir.maxpos.z. Z++. And we'll then do that for x and y as well. I missed one. May I link a helpful C++ document about this? Sure. Okay, so we've got our z, x, and y. Copyolision. Ah, gotcha. Yeah, I will read this after stream, but I definitely should read it. That's not... Okay, hold on. I need to manually type it because my stupid... Wait, no, I can just open a new tab in here. There we go, okay. Alright, so we're iterating over... If you read the first paragraph, alright, sure, let's see. Emits copy and move constructors, resulting in 0 copy path by value semantics. PR value semantics guarantee copyolision. Since C++ 17, a PR value is not materialized until needed, and then it is constructed directly into the storage of its final destination. This sometimes means that even when the language syntax visually suggests a copy/move, for example, copy initialization, no copy move is performed, which means the type need not have an accessible copy move constructor at all. Examples involve initializing the returned object in a return statement, where the operand is a PR value of the same class type. Oh, that's only if you construct it here, though. Yeah. It looks like that's only mandatory if, for example, this was actually initialized right here. Okay, so we have our variables. We're gonna probably grab our world position here. So this is the job position. Why do we have the world position? Oh, I guess, yeah, that makes sense. So we're gonna grab the job position times the chunk size. Then we're going to add in z, x, or x, y, z. Big if being that value is not const. Yeah, fair enough. I just realized I've done this in a way that's really obtuse for myself. We're gonna go from 0, and then we're gonna go up to size, and then we're gonna have ourselves a let int pos is going to be equal to z, x, y. I can't type. Okay, then our world position is going to be the jobs position times the chunk length plus the end position minus the structure, or minus the offset? I guess minus minpos, because minpos is going to be the position... Yeah. No. What? This is breaking my brain. I think minpos is going to be the actual position that we're starting this whole thing at. And then endpos is the position incremented into it. Yeah, so that's the world position. Then our local position is going to localize to the specific chunk, and the chunk position is going to get the chunk index within the world. Then we need to get the chunk, so yeah, that makes sense. So we grab the chunk, and then we need to get the index into the blocks array, which we're going to do via passing x, y, z into here. This will give us the array index, which we could actually compute on the fly if we wanted to. And we might do that later. Well, I'm actually going to write to do compute rolling int. Okay, then our chunk index is the index into the chunk. So I'm actually going to call this struct int, or stir int. So this is the index into the structure's data. This is the index into the chunk. Then we're going to set the value. And we're going to ignore that for now. Okay, that should place each structure, I think. Probably. Which means that if we actually had a structure to test it with, we could try doing this. Right now we don't. In fact, this is not compiling because there's no value over here in decoration def. Oh wow, this is old code. Okay. So a decoration refers to a structure that's placed in the world, like tall grass or a tree or whatever. It's just a decoration and it also contains, or it's a structure and it contains placement parameters. What does U32 expand to? It's one of the size types. It's uint32t. So we don't need depth, because depth is now encoded in the structure. Yeah, no, I used to have it just as int, and then someone told me about the fact that those are not guaranteed to be sized, which made me sad. So this can stay as it is, the noise can stay as it is, this is fine, and then we don't need to encode the orientation, I don't think. Wait, int is only at least 16? Oh, that's why long is also 32 bits, right? And you have to do long for it to be 64 bits. And then if you do long, it says it's too long. Ah, that's such a lame warning. One of my linters used to say, value is too long for C++. And I was like, wow. Now it just says that long cannot combine with previous long. Fine. Yeah, because short, I think, was added after, right? Because we initially had char and int and then long. Yeah, such a clean language. It's a beautiful language. I love it. I love C++. It's perfect. Okay, so our decoration depth takes an identifier, name, tags, depth, place on, noise. We don't need it to take depth. Section, max level, structure, which is a shared pointer? Ew, why? Okay, that can be a unique pointer. I don't know why that's shared. And it should not default. Oh, okay, that's probably why. It's because it needs to be default initializable, but that's still, like, we can still do this. And then the orientation is encoded within the structure itself. Don't need to copy depth, and we don't need to copy that, and then we do need to move that. Perfect. Also, char can be the same length as int, which can be the same length as long. It's all legal. Yeah, types are great. We love the basic C++ types. Okay. So, that defines our decoration def in a way that makes sense. Except there's an error here. What? Oh, that's just an old error. It's not deleting itself. Okay. Can we try building this? I think this is going to crash because there's places where we initialize decorations and we don't use the new structure format. But that is what we're trying to find. The easiest way to figure out what code doesn't work is by trying to compile it and seeing where the errors show up. Boop, 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 boop. We're almost done. Oh, okay, 4 errors. That'll do it. I see that, yeah. Okay, build failed. Okay, it looks like it's just these. So, yeah, this decoration atlas interface is the part of the code that converts a JavaScript decoration into a C++ decoration. If we go and look at decoration in .ts, case sensitive, this is the main file that has it, biome. This decoration property here is the decoration atlas interface. So if I go back to decoration atlas interface, you can see this function add is a specialization of the atlas interface's add, which is used in the C++ file somewhere. Atlas add. Yeah, it's used in here. Right here. And so, effectively by specializing this function, we specialize the logic that gets called when we call decoration.add here, which right now is reading this old format structure, which is somewhat similar. If we go to tree small leaves.json, it's similar in concept. It contains indices and nodes and origin and size, but it doesn't have any of the properties that we have in this file, tree.structure.json, which is the more advanced version. One thing that's not good is that this RE world edit void thing is passed in here. This is going to cause us some issues. I guess to demonstrate what the hell that even means, let me... That's not going to build. Of course it's not going to build. Let me try running Zepha, and I think that we'll be able to demonstrate this. So tree is called just tree. So if I give myself an origin and I go structure load tree... Yeah, perfect. So you can see all these red funky blocks, right? They're effectively just saying, don't delete whatever was already here. If we just had an error block in the structure, then it would actually set that property to error. But these voids indicate that it shouldn't do that, and it should just be whatever block currently exists. So like, for example, if I go structure generate tree here, you'll see it generates the tree, but it leaves these blocks that were already within its bounds as stone. However, that's part of the JavaScript. These void blocks are mostly for debugging purposes. What we actually need to do is when we pass the structure into C++, it needs to not be these voids, which are a modded block. It needs to be unloaded or something, which is a reserved identifier. That's a JavaScript side issue, and I don't want to deal with that right now, so we're just going to pretend that isn't a problem. Wait, the minimum size of a long is 8 bytes, but its size of can be 1? Wait, how is that true? Does size of not have to return the actual size by the spec? Oh, because size of is a division with the size of char. Char is at... Oh. Oh no. That's terrible. Oh my god. Okay. I guess that makes sense. Give me 1 sec, I'm gonna refill my water. It'll only be a moment. Water restored. Actually, while I'm fucking around with stream stuff, I want to get the chat in the stream starting soon screens. I'm just gonna stick it like here. Does someone want to type a message in chat to confirm if that's actually working? Paste reference. Paste reference. Okay, I saw that message, but I'm not seeing it in here. Why not? Wait, has the YouTube chat not been getting mirrored? Like, at all? Huh. Hold on. Wait, it has been mirroring. But it's not mirroring... It just didn't post your message. That's really weird. Yeah, wait, hold on. I just ignored that one. Sure, I guess. Does an American furry measure in paws? I would not be the authority on this. I'm Canadian. But, you know, you would hope. That would be only right. It doesn't want to be greeted, I guess. Okay, there your message is showing up. Okay, so it's just being weird. Alright, cool. Happy, good. Okay. So, we have this new tree structure. Also, the music stopped. No. Where'd the music go? Wait, why is it gone? Oh, there it is. Okay, so we have our tree structure. And then in biome, we're trying to create a structure from parsing this value. This structure create method is defined in native code. Hold on. Oh. Okay, yeah, okay, so this converts it into a C++ object. Which is interesting. Do I actually want to do that? So I guess the question is, do I want to make it so that you have to create structures? Or do I just want, like by explicitly calling .create, or do I want it to just attach invisible information to any structure which is created to cache it, effectively? So like, I think I do this somewhere. Yeah, there's funky stuff with the metadata things. Have a good sleep. See you later. I think what we'll do is we're gonna make it so that structure.create exists. And it can be called either with literals, so we can either go structure.create, and then that gets all of the properties that like have previously been in the JSON file, so like JSON stuff. Or you can go structure.create with just a path. And then that will load it and do that. So then we can either load it from a file easily without having to do json.parse and fs.readString, or we can just initialize it inline, which we do in some places here. If I go to where structure.create is called, yeah, there's lots of places where we just initialize it inline because it's like a single block structure. And it would be nice to also have a specialization that just creates a single block structure as well. Alright, so... Oh my god, I'm so tired. Okay, so we're going to go into our structure interface. And we have this create method, which calls create structure. And it's either going to have an object or a string as its properties, right? So we're going to simplify a lot of this logic here, where initially we're just going to grab the argument. So let's go. Also, why are these vars? Let's make these lets if we can. Okay, so let val or arg is going to be args0, or we'll go if args0 dot is object or dot is string. I think I actually have a method for this. Is string arg0, which checks if it's a string or a string object, because that's a thing that exists. It's kind of infuriating. Okay, so if it's a string, then we want to load the file. Let's look at the file system interface for how we do that, because I don't remember how it works. Yeah, all this code is super funky, and I bet that sharing it on screen one day is going to end up with a breach in my security. Don't worry about it, we'll make sure it's all sorted before this is published. So we have open and try open. Open just takes a series of arguments, and then it grabs a path. Then we call create file handle path and create, which returns a file handle. And then what does the file handle do again? File handle data. That's an internal field. Cool, so that... Cool. So this basically opens the file. And then... Where is the file handle? It's instance template. So what properties does this get? It gets read, read string, write, resize, sized, and close. Cool. Okay. There's a function somewhere in here just called instance read string. Or wait, no, not instance read string. There should just be, yeah, read string, which just gets the path, gets the system path out of it, checks if the file exists. If the file doesn't exist, it freaks out, it reads the string, and then it read string from args, reads it, and then sets it to a v8 string. Okay. We're going to do some slight restructuring here. We're going to create a function called readString that's public, which is going to return a string. And it's going to take into it a... I guess this should probably be like an optional of a string, because it could freak out if the file doesn't exist. Actually, I guess we throw for that, so we don't need to. This is going to take in a path, and then that returns a read offset and a length, or takes a read offset and a length. So I guess we'll grab that. So we'll go const string and virtual path u32 read offset equals 0, u32 length equals 0. Then we're going to implement that. So we're going to go void script file system interface read string, which is going to take in a all of the properties that we already specified. So virtual path. What else was it? U32 read offset and then U32 length. Okay, and then we're going to do a lot of this logic in here. So we have read string down here. All of this stuff. Wait, do we not call read from string in here? Oh, read string from args is all the way down here. Alright, so we're gonna basically just go read string, convert string args 0, and then convert u32 args 2, convert u32 args 1, I believe, is the code. Because our string from args function, it takes a file size, or sorry, it takes, right, okay, this shit's wildly stupid. Okay, so we're actually probably gonna get rid of read string from args unless it's used in multiple spots. It is. In read string and instance read string. Oh, okay. Damn it, that kind of makes sense. Have you heard of arena allocators? Lots of small heap allocations for things like strings can slow things down. One approach is to allocate a big block up front and use chunks out of it. Allocations this way can be as simple as incrementing a pointer. It might be an idea for making these string things more efficient. I don't think that I'm using many heap allocated strings here. I could be wrong. My eyes have been kind of glazed over trying to stare at this. But a lot of these things where you see a string with a capital S is actually a V8 string, which is just a pointer to JavaScript memory, so presumably they're already doing optimizations for those. Yeah, no, the V8 integration stuff is really fancy. I like it a lot. So I guess what we can do is we can pull out all of this shit out, and then just call that stir is going to be that. Then we'll go to the implementation up here. Differs from its interface, really? What? How does it differ? Oh, static must use string. There we go. Okay, so this is going to grab the virtual path. So we already have the virtual path. I guess this can't be static, can it? We need to actually reference it. So let's go like this. Then we'll go get system path. Cool. File exists. We're going to make sure it exists. If it doesn't, we're going to throw. We're going to grab the stream. We're going to open it. And then we're going to get the file size. Where did that go? Where did that file go? Okay, we're grabbing the file size, and then we're tossing it into read string from args. And this is where I think some stuff can change. So let's grab this logic, and let's just toss this in here really quick. So read offset is going to be... Okay, so we're going to say specified read offset, or let's just go like rec read offset, and then rec length. And we're also going to make this a U size. And we may as well make this a U size too if we're supporting very large files. Okay, so we have our requested read offset and our requested length, and we're going to get the actual read offset and actual length by grabbing the requested read offset and minning it with the file size. Why is this an I size? Is file size an I size? Oh, that's just the read function. Okay, hold on. I assume that there's a reason why I've been using signed sizes. I'm guessing there's like an error code that can return -1 or something. So we're gonna throw that everywhere, and then in here, when we're actually calling our read string, we're gonna actually call convert isize args 2 0, isize args 1 0, which will default them. Okay. Now we don't need the conversion here. We're just grabbing the requested read offset and the file size, and we're minning them. And it doesn't like that because this thing is a pos type, and I have no idea what that is, but we're gonna convert it into an isize. Take that. Okay, and then our length is going to be rec length minified. Oh, the rec length is by default the file size. So we're actually gonna go rec length equals 0 question mark file size colon rec length. Or I guess we can no, we can't do or like that because it's not JavaScript. So this is gonna grab the full file if the requisite length is 0. And then we're going to max it out by file size minus read offset so we can't overflow the read. Then, why are we storing this as a char vector? What is read? Read takes a char pointer. Oh, okay. So I guess we could make a string which has a length or I guess we already have the vector of chars which reserves the length, then we read the data, and then we need to go string s is going to be out.data out.length or out.size. I think that does what I want because it takes a pointer and then a size, but let's confirm. Okay, string constructor, there's like 17 of them. Confirming here, yeah, const char s size tn, that's 5. And it says copies the first n characters from the array of characters pointed by s. So yeah, so this creates a string. And then here we convert it into a v8 type, but we're not gonna do that here. We're also gonna close the stream, and then we're going to return s. Why is that not happy? Oh, semicolon. Semicolon. Boop. Okay. So that reads our whole file, okay. And then if we go back down to here, we have this string, which is coming from here, which needs to be a member function. That's why we have self. The function's not marked const. That's fine. It can be const. It's just not marked that way. Okay, back down to here. So now we have this string, which is a const string. And then finally we need to go stir object is going to be a v8 string, which is going to take stir. Which it doesn't like. New from UTF-8. Oh, I guess it expects a C string. Okay, sure. So we'll go stir.data, stir.length, or stir.size. Cool, so that creates the local, and then we want to just set the value to stir obj right there. Okay, cool. That was a refactor and a half, but now read string should be deferring to our internal read string. And if we go down to instance read string, we should be able to basically do the same thing here, where we ensure the handle's open. Oh, interesting. So this takes in a stream. So there's a weird way in which this probably is actually good to keep separate. Because we're creating the stream in here. Which I guess we could... Yeah, I do not... I don't like this code I just wrote. It's really bad. Okay, for now, I'm gonna write to do... There's a very strong... there's a lot of dry in here. And then I'm actually gonna revert this because this is worse, like, efficiency-wise. So we're gonna undo that. Undo this. But we still have the function we need, which is read string. Now, if we go all the way back here, if we got a string, we're gonna go let data is going to be, if this value is a string, then we're gonna go self dot, or I guess we need the file system interface in here to be able to access it. So I guess we'll go file system interface fs in here, and we're going to store it, which we're going to pass in here. Cool, so now we have the file system. And then what we can do is we can go self.fs.readString, and we're going to read the path, so convert string args0, and then we want to parse that, which I think JSON... Yeah, parse takes in a context, and then a string. So we can give it the context, and then the string right here. Although this is a C string, which means we need to... Oh man, okay. This is where we use the block expression. Here we go. So we're gonna have a block expression, and we're gonna go let stir is going to be equal to this whole mess, which grabs the string from the file. Then we're gonna go let stir obj is going to be equal to v8 string new from utf8. It's going to take the isolate, the string's data, and then the string length, or I mean the string type, and then the length. Cool. And then we're going to finally parse that string value into an object, which does not work because this is const and not checked. So let's first of all check it. Okay, and then if we don't have a string here, then we're just gonna go as, or args0 dot as object, which is gonna convert it to an object or freak out. Okay, so now, oh, and then to local checked. Okay, so now data should be a v8 object. Maybe. Yep, so we have a local object here, which was retrieved by either reading and then parsing this file, or just grabbing the object literal if it exists. All that work to effectively just let us pass in strings. Now, we actually need a structure, which is going to exist. And then we need to initialize all the properties in it. So I'm just going to comment out all these properties in here. Okay, and we're going to go and do this really simply. So we're going to go structure.identifier is going to be equal to convert string data, or I guess get string data identifier. It doesn't like that because we need to include common script object. Then it doesn't like that because this is const. Cool, okay, better. Now our structure size is going to be equal to get ivec3 data size. Basically, this get helper that I wrote just converts JavaScript types into native types. Structure dot offset is going to be equal to get ivec3 data offset, and we're going to default it to just an empty vector because we do not care if offset is specified. Okay, nodes is going to be a mess, so we're going to do that right now while we just finish this, and then placement type is going to be funky. So in the JavaScript structure definition, it's either a object with the type set to rigid or an object with the type set to terrain matching with a depth. So in C++, we're going to go let placement obj is going to be equal to data dot get context, and it doesn't like that because it wants a local value, convert string placement. Cool, so that's our placement object. Then we're gonna go switch, or sorry, not switch, we're gonna use match, which is something that I wrote that's horrifying. And we're going to go get string placement obj type. Cool. This needs to be a both a variable and it needs to be a to local checked. Okay, and then we're gonna go case rigid. This doesn't like me. Requires expression of integer type. What's wrong with you? Oh, do I still need to do util hash in here? Oh, that doesn't work. Oh, does it have to be a C string that I pass in? No. I swear I did this and to let it like support strings. Okay, I think that's right. So case rigid, we're gonna go structure dot placement type is going to be structure placement type rigid, and structure dot placement depth is going to be equal to 0, and then case terrain matching is going to be equal to structure dot placement type is going to be equal to structure placement type terrain matching. Structure dot placement depth is equal to get I32 placement obj depth. That should have worked. Oh, I just auto-completed wrong. There we go. Alright, cool. So that should give us what we need for the placement type. You find this very interesting. It's like transpiling C++ into Rust. Yeah, copying between two different languages is really interesting. The V8 library is super powerful, but it's also very verbose, and so a lot of these helpers are hand-rolled things that make this a lot easier. Like get is this horrible atrocity of template types. which gets pretty insane. And then object is even worse, because it's basically a bunch of the getters, but with other template types for getting objects and stuff. But it makes it a lot more usable. This match statement is actually some horrible macro thing I created. It's all of these macros, which end up allowing a lot more powerful of switch statements to be made, basically. They don't implicitly fall through. You have to actually write fall through as a macro to make it work. And then cases can take like multiple valid matches. Why are people phone calling me today? Jesus Christ. One sec. So cases can take multiple cases, and they can also take string literals. And they will get converted using a hash function into integers. And then there's also like implicit braces. So like in default C++ switches, you have to do this to get like your actual, you have to do this to have a different lexical scope. Otherwise, all of the variables you specify in the switch statement are global for the function, which is awful. It's just a whole thing I made to try and make this a lot nicer to do match stuff in C++. That's also what this macro is, the immediately invoked function thing. It's just a macro, but it lets me do block expressions. Okay, so now that we have this placement, that's cool. We have placement type and placement depth. Then we're just going to, I guess we can't ignore fixtures yet, because to place the structure, we need to get a source fixture. So we've got to parse the fixtures. I can't avoid it forever. So we're going to go data. That's really cool and kind of insane. Thank you. It makes things very unreadable if you're not me, but I'm the only person that I ever expect to work on this project, so I'm not too worried. And hey, eventually I'll be that type of person where, like, if this team, like, if I end up getting a team for this project, it's gonna be just like the job I just had, where I'm joining in and there's absolutely incomprehensible code style stuff happening, and I just have to try and figure out how to understand it. I'll be my own worst nightmare. Okay, so we're gonna go to, we're gonna grab the fixtures property from the structure. I'm just going to quickly confirm all these types are what I thought they would be. So you have placement, identifiers, nodes, meta, name, size, offset. Fixtures, okay, they have a position, they have a source, and they have attachments and an orientation. I'm going to grab this and comment it so I can easily see it. Okay, so we're grabbing the fixtures property, and we're going to get it as an array. This is the V8 type, right? Yeah. I have like namespace aliases for the V8 types in these files. Okay, and then we're gonna go to local checked. So we're gonna try and get the fixtures array. And then we're gonna go for let val of fixtures are. I don't think that works. No, I think I have to go for let I equals 0. I is less than fixtures are dot length I plus plus, and then I have to go var fixture obj is going to be fixtures are dot get context I. And this needs to be a var. Cool. Okay, so that gives us each fixture, and then our fixture has a position, a source, and an attachments, and then an orientation. So first of all, let's create a fixture object. So we're going to go let, or var fixture is going to be structure fixture. I guess what we can do is actually go structure.fixtures.inplace back a new fixture, so it's created in place. Cool. And then we want a reference to it. Then we're going to grab, okay, so fixture.pos is going to be equal to get fixture object, sorry, wait, get iVec3 fixture object pos. That should work. Why is that not working? Oh, it's a maybe local. To local. Cool. So we're grabbing the position. And then we are going to have to handle the source, which... Oh man, I can't wait. Okay, so the thing about fixtures is that source can be null and attachments can be an array. So what we really want to do is go if fixture obj or is null. Do you use Linux? What's your API, OpenGL or Vulkan? This is Vulkan, and yes, I do use Linux. So if we go fixture obj.is null, no, is, okay, get, oh, this needs to be as object. Okay, if we're getting the source, and then it's not null. Why are you still mad at me? Okay. I love V8. It's great. Okay. Now if we go, if this is not null, or is null, so I guess we'll grab it as a source obj. So we'll go, I like your VS Code setup, mine looks ugly. I put a lot of effort into making my editors look good because they make me just feel really gross otherwise. If you're interested in the theme and stuff, the color theme is AU Mirage bordered. It's just on the extension marketplace. And then the, I don't know what the syntax theme, highlighting theme, is it just all AU Mirage? Like, yeah, I think so. And then the product icon theme is feather icons. And I think that's all I've done. There's not really much else happening in here. I guess I've got like the material icons as well for the files. Oh shit, my headphones just died. Come back to me. Ah. I still can't hear anything. One sec. Gotta switch these out. Okay, boot these up. Perfect. Okay. Is the audio still coming through? It looks like it is. Okay, so we're gonna get this fixture, or the source obj here. And we're gonna go as object. Then we're gonna go if not source obj.is null. This might be putting the cart before the horse here. I'm not sure if I'm allowed to cast it with as before checking if it's null. But if that doesn't work, we should be able to see that pretty immediately when we actually try to run it. So if the source object is not null, then it's going to be a thing of this type. So then we're going to create a source. So we're going to go fixture.source, which I believe is an optional, yeah, is going to become, where did I go? Option, or I guess we can just specify it as a structure fixture source, like that. And then can this just be inlined? Identifier, initializers, and wait. Some of it can. We're gonna go identifier is just going to be get source obj, or string, source obj identifier. And then initializers, we're just gonna set to an empty object, like right now, and we'll just do 2D counters. And then wait is going to be get f32 source obj wait. And that's angry for some reason. Oh, because it's out of order, because when I checked the property names, it didn't print them in order. What? Okay. There we go. So that's gonna set the source. Good for us. And then we're gonna go var attachments obj is going to be equal to, or attachments are is going to be equal to fixture obj get context convert string attachments to local checked as object, or not as object, as array. Oh, I have no idea why I coded that. My brain's rotting after 2.5 hours of streaming. Then we're gonna go for var j is equal to 0, j is less than fixtures or attachments r.length I++. Let our var attachment obj is going to be attachments r.get context I as object dot to local checked. Then we're also going to inline initialize this here. We're going to go fixture dot attachments dot inplace back structure fixture attachment. Oh, a nice convenience thing we can also do here for slight optimization is we're also going to go fixture dot attachments dot reserve attachments are dot size or dot length, just so that we're not expanding the vector. And I guess we can also do that here, where we can go structure dot fixtures dot reserve fixtures are length. Just a super micro optimization, but it's nice because it means that we don't have to shrink to fit at the end. Because vectors are dynamically sized, the way C++ works is it reserves incrementally like double the space. So a vector might start with like, say, 1 slot, and then if you add 2 items to it, then it has 2 slots, and then if you add 2 more, it becomes 4 slots, if you add 4 more, it becomes 8 slots. And it keeps going up in powers of 2. And you can shrink it to its exact size by calling shrink to fit, or you can reserve it to a specific size, and then unless you go over that specific size, it won't allocate any more memory at all, which is more efficient. Okay. So, now that we're placing back an attachment, we need to go counters, identifier, and wait. We're not going to do anything with counters yet. Identifier is going to be, well, both of these are going to be the same. And this wants to go down here. Perfect. So that is going to add the attachments to the fixture. So the fixture is good, maybe? No, it's missing an orientation. Fixture.orientation. What is the orientation type right now? It's a number? Is that for real? Oh yeah. Okay, cool. I'll probably make that an enum at some point, but it'll still end up being a numeric enum. So what we can do is we can just have a convenience method, since we're realistically probably going to need to do this in a bunch of places. We're just going to have a method for now that just says void toOrientation, or I guess structure orientation, toOrientation. And this is going to take an I, or a U8. Oh wait, no, I don't need to do that. I can just static cast it. We can just go get U8 fixture obj orientation default to 0, and then go static cast structure orientation in here. There we go. So that copies the orientation. And other than the to-dos, which are kind of big, given that we don't have the nodes in the array, or in the list yet, I think that's everything. I guess we probably should try and get the nodes in, because otherwise we can't test this at all. So this is slightly weird, because in the structure files, so basically the way that Zephyr works is that internally when the game is running, all values, all nodes are just integers, but those integers are not necessarily stable between runs. So you might have like stone in one run be index 1 and the next run be index 10. It all depends on what order mods are loaded in, which I don't want to require to be constant, right? So when you're serializing information to a file, I use string IDs, which are supposed to be constant. So you might have Zeus default stone as a stone type. And so in the file here, so in the structure type, which is meant to be serialized into JSON, what we have is we have an identifiers list, which basically just stores a whole list of node identifiers, all of the different identifiers that could exist within the structure. And then we have a nodes list, which is an array of numbers. And we do that so that we don't have to like have just a ton of strings in an array. This can still be a number array, which is a lot more efficient for storing on the file system. And then those numbers key into this identifiers list, which then when we parse it, we need to key the identifiers into the actual runtime numbers. So I've got a lot of code that kind of already does that here, and I'm gonna see if I can just get away with reusing it. So we have this nodes are and indices are. What it should be called is nodes and identifiers. So we'll go identifiers are, this should be data. Force place is not a thing right now. Now we're gonna resize the nodes list. So structure dot nodes.resize to the length of the nodes array, that's fine. Then for each item in the nodes array, we're gonna set the nodes in here to items. So we're getting from the items list, so items is our items registry, and we're indexing into it at the string ID that is gotten from identifiers are at the nodes index. So we're taking each number from the nodes array. We're getting its string identifier by keying into identifiers are with that. And then we're getting the actual runtime number from getting the actual definition from our items atlas and then pulling out index, which is a number. I think that's it. I think. So I don't know why this is red. Oh, it's just GCC being slow again. Okay, now I guess we need to make our instance. Yep. We're not gonna set anything on it right now. This is kind of weird. What I actually want to do is freeze this object and then give it a bunch of stuff in its prototype, but we're not gonna do that right now. But we are going to create an instance data, which is effectively just the type of data that this is going to hold, which is just going to be a shared pointer to the native structure. Which is weird, actually, because this is a stack allocated type. I guess realistically it probably makes sense to make this a shared pointer. I'm trying to think if this makes sense. Yeah, I think we'll make it a shared pointer for now, because we don't actually have a structures atlas. We're not storing all of the structures in any specific spot. Which means that a shared pointer is the easiest way to do this. I'm just gonna replace all these dots. Okay. So our instance is going to be there, and our instance data is going to reference the structure, and then we're going to set that property. We're gonna give it a garbage collection callback to actually remove that pointer when when the actual instance disappears, and then we're gonna return the instance. Okay. Why is there a shit ton of errors? Oh, okay, well that would do it. Okay, we've still got errors down here though, which is weird. Let's try building it and see what happens. It actually doesn't like it. Let's look a little bit more closely here. This does not like pulling from placement obj. Do I need to give it as object? I might need to do that. Because I think that I've got specializations for get being an array or an object. Static assertion failed due to requirement is base of array value type check. Where the hell is that? Here? This returns... Okay, wait. Static assertion failed due to the requirement is base of object value type check. What am I looking at? Do I need to do the check first? Yes. Okay, now we're just breaking here because this doesn't make any sense to it. I forgot this whole step existed. Oh boy. Let's not listen to this. Let's just ignore this and this, because I'm pretty sure neither of these properties exist anymore. Yeah, because those are the decoration properties. We just want to give it the structure. Okay. Okay, let's keep it going. What's wrong with this? It doesn't like that this is a right. Okay. So the reason that this in the decoration def was a shared pointer instead of a unique pointer is because we're passing it in a shared pointer, because that's the data structure that we need to have from the atlas. Okay. That all checks out. Build, please. Please build. Oh my god, wait, is it gonna build? Nope. What the fuck just happened? Candidate not viable. What are you complaining? Oh, where we actually call this. Yeah, this needs to have file system. Okay, file system needs to be defined earlier, clearly. So Zepha, this is the thing that contains all of the information, or all of the atlases and the stuff. So we're gonna throw file system at the top here, so that it can be defined before everything else. Which means that we can actually give it to our structures here. And that's not going to work. Something is wrong. MapGen is sad, but this is weird. Oh, because this is before toLocal checked again. Okay. Fix that. Okay, we still got an error here, because I did it again. Whoops. It's weird that that's like a defined function if it's just an error. I imagine there's some use for it. Okay, there we go. Now in MapGen, what the fuck is this? Generate chunk decorations. Oh. Wait, I'm confused. What is happening here? So... Oh, this is just cool. So we just need to go structure depth in here. Cool. Why is that mad? I don't know if that's actually mad. I think it's confused. No member named depth. Decor, structure, placement, depth. Please be happy. Please build. Please build. Please build. Please build. Holy shit. Oh my god, it built. Okay, now it's gonna crash at runtime. Yep. Psych fault, though. That's not... Yep. Okay, wait. Let's debug this. We just gotta wait for a clean build to happen, which is gonna be annoying. But we're getting there. There shouldn't be a seg fault. Well, I guess there could be a seg fault if we were trying to pull information out of the struct that doesn't exist. Technically, we should be checking that stuff, but we're not. All right. Building, building, more building. Okay, almost done. Okay, show me where the seg fault is. Okay. We crashed here. Here. Because if we pull up our biome file, I don't even think this has an identifier. Yep, okay. Okay, so it's assuming that it exists, and then it doesn't, and then it breaks. Okay, that is actually to be expected. We need to add error checking later, but for now, I'm just actually gonna comment out all of the structure creations that are not valid. So let's change this, and we're just gonna call this tree, and we're actually gonna load in our proper tree structure, which is going to be in, where is it? Assets? No, data. So that's tree small leaves. World edit has tree.structure.json. We're gonna go Zeus or Ari world edit. And we're gonna go data, Ari world edit, structures, tree.structure.json. Cool. Good. We're gonna need to change this create definition, which is in here. It needs to take either a structure def, which is going to be some other shit, or it's going to take in a path. And let's go into the code, and we're going to go assets npm run dev, build a new type defs. Okay, now this should be okay. It's not assignable to path. Why not? It should be assignable to path. It should definitely be assignable to path. Oh, static game or world. Okay, game, not data. There we go. Alright, so let's keep going. Where's the rest of the structure.creates that are not commented out right now? We're actually just gonna grossly comment out... I don't really want to do that. Okay, we're gonna quickly change the type for the structure here to be a bit simpler. A simpler version of this one. So it's gonna get... Hey Smarty, how you doing? It's gonna get a name, which is a string. It's gonna get a size, which is a vector 3, an offset, which is a vector 3, and identifiers and nodes. We're not gonna pass in meta. Okay. Then we're gonna have fixtures, which is going to be an empty array. And why is this sad? Because all declarations of size must have identical modifier. Oh, I know what's happening. Okay. Okay, and let's build the stuff again. I am 3 hours deep into refactoring the structure code, and I'm really zorped. But I hope you're doing well. Okay, now that's happy. Now if we go over to here. Okay, so this is basically the same thing, just this needs to be identifiers instead of indices, and then pass through needs to be known as an identifier. Cool. And flower needs to be also known as an identifier. And it's sad because we're missing a name, a fixtures array, and an offset, which we're just going to blank out for now. Okay. Structure code, so that you can make unreasonably cool auto-generated tree branches? Yeah, that's the goal. I'm mostly just working on taking the system that I've already had functional in JavaScript and getting it into C++, since that's important to make this all work. And it's kind of annoying to do so, because the format of things changed. Lily pads don't even generate. This can be commented out. I need to change this biome file. It's like so many commented out lines of stuff that's like kind of unfinished. Okay, identifiers. But yeah, I think these structures should be the bare minimum that are needed to actually function properly. The empty fixtures list will fuck it up though. Oh, fuck. Yeah. That's annoying. Oh, man. Don't want to deal with this right now. How do you go about making people able to add content with JavaScript? Do you make them write certain functions, or how do you give them access to content creation? Basically... Sorry, I'm just checking. Yeah, okay, we're good here. Basically, I have a file called called Zepha, which exposes a bunch of native code as modules to JavaScript. And then in the JavaScript code, you can index into it and pull properties out. Like, there's a lot of stuff in here that's available. For example, fs, which is a file system, noise, which is noise parameters, decoration, and structure, and item, which are registries. And then you do stuff by calling functions there. So for example, if I go to decoration.add, you'll see that this is calling the add function on a native object that's gotten from the module. It's actually decoration atlas interface. And you can see the add function just does a bunch of C++ code and adds stuff to the registries that the C++ generators use. And then that stuff is just added into the game by virtue of being in C++ now, basically. Okay, so I need to add sources to all of these, which... This is gonna break my brain. Let's just copy this type over to here. Then we're gonna make this a structure fixture array. We're gonna have a export type structure fixture, which is going to be equal to all of this shit. I don't know why I have orientation below these. And then we're gonna have structure source or null. And that's gonna be like this. We're gonna have export type structure source, which is defined exactly to this, where this is happy. We're gonna have structure orientation be redefined to 0 or 1 or 2 or 3. We're going to comment out this stuff right now. I have a friend who writes cool JavaScript website stuff. How do they live without types? They just write my variable equals 2 and it's just a number? Well, I mean, I personally use TypeScript for everything. That's literally what I'm defining types right now. But yeah, some people just don't do that and just use like no types, and it's super weird. I don't know. I don't think I could deal with it. Structure attachment array. We have structure attachment, but it is not at all the type we want because it's super old. So we're gonna do all that. So we have structure source, structure attachment, structure fixture, which uses both of them, and then structure def, which combines everything. Okay, and we're gonna build. Also, do you use Vim movement stuff or just arrow keys? I use arrow keys, but I have a weird keyboard layout that puts the arrow keys like right in my way, basically. If I open up Oryx, so my arrow keys are right here, which are really easily accessible by my thumbs, because my thumbs are usually just sitting on this area, right? And then I can just like move them up to hit the arrow keys. Yeah, I have a split keyboard. It's evil. It's kind of cursed, but I really like it. I might have to end stream soon here, guys. My throat is starting to, like, combust. Okay. So, now that we have the proper types, if we go back to biome, we should be able to go down to where I've defined the fixtures here, and we're gonna go source, which is going to have an identifier, which is just gonna be empty, or just like that for now, super scuffed. Initializers, which is going to be an empty array, and then weight, which is going to be 1, and then attachments, which is going to be an empty array, and then orientation, which is going to be 0, and then position, which is going to be 0, 0, 0. This is so much overhead, and we're going to make a helper function to make this a lot simpler to define. But for now, I just need to make sure this works, so if I just do that, where do I define fixtures? Like that, I can just control H with that. Kind of. I should get rid of the leading tabs. And I should get rid of the trailing comma. There we go. I didn't like that because that was commented, sure. But otherwise that's good, okay. Let's go to Zeus and build it, and we'll see what happens. Okay, and let's run the code. I actually already know this is gonna break. Okay, that's not why I thought it would break. The fuck? Failed to load world fragment shader. Okay, hold on. I think I know what's happening. Yeah, it just got rid of the links that I had in here. Let me just grab these, put them in here. Wait, they're in there already. Why is it failing to load the... Hold on. Oh no, throat hurting bad. Okay, one last question, not to make you uncomfy. How do you store structure elements? Is that just JSON or pure stored bytes? So the files that are... so basically... What is happening here? Exit. So in the actual file system, they are JSON. If I go to tree.structure.json, it's a JSON blob. And then when we ingest it into C++, it becomes just like an actual proper data structure. Okay, empty to local checked. So that's what we want to see. Let's go see what it failed on. It failed on this empty, which happened... Oh. Okay, that's very weird. That's going to be a whole nother rabbit hole. It's not actually finding the argument. But yeah, guys, I think I'm probably going to end the stream here since I really need to go eat some food and drink some water and not talk for a couple hours. So... yeah, we'll pick this back up next stream, and we're going to try and figure out why the hell it's not even processing the structure. I would debug it now, but I have a feeling this is going to be a whole rabbit hole. And we've also already been going for about 3 hours. So, yeah, we'll end the stream here. I will catch you next Sunday at 12 p.m. PST. Regular time, regular place. If you are interested in getting stream announcements, I post them on my Discord, which is linked on screen in the bottom right. Otherwise, thanks everyone for showing up. I really enjoyed hanging out and working on this. We got a lot done. Like, a lot done. There was a lot of files changed this time around. But yeah, if you hop in the Discord, I'd be happy to chat. Otherwise, have a great day, all. Hope you get comfy real soon after stream. Bye. No Matrix? No Matrix. Oh, like no Matrix social media? No, I haven't used Matrix. I mean, I messed around with it a little bit, but... it's nice to have everyone in one place, I guess. So I've mainly been using Discord. Alright, well, bye everyone. See you next time.